So in this video we consider the case of a first price auction with private valuations where VI is player I's valuation and BI is player I's bid, and we suppose a very special case in which VI, so for each player I, the valuation is drawn from a 0 to 1 uniform distribution. So each real number between 0 and 1 is equally likely. And I guess you guys know what a uniform distribution is. If you don't, that's a good question to ask me during the Zoom meeting. Another property of the uniform distribution between 0 and 1 is that its probability distribution function looks like this: 0 and 1. Each value is equally likely. This is the probability on the y-axis. And what that means is that the likelihood of getting a number between 0 and x, where x is, let's say, a number between 0 and 1, is exactly equal to x. So if x is, let's say, something like 0.2, then the likelihood of getting a number between 0 and 0.2 is 20%. The likelihood of getting a number between 0.2 and 1 will be 80%. We're going to use that property of a uniform distribution here. Okay, what we want to show here is that this bidding strategy, where you bid exactly half of your valuation, that holds for all players, then that is a Nash equilibrium. That's what we want to show. And the way we show that is by saying, let's suppose that all players do that. If all players do that, then the expected payoff for player I from following that, from other players following that, will be equal to this. Whenever player I bids a value that's greater than a half, player I will win the item for sure, right? And get a valuation that's equal to VI minus BI. Does that make sense? Because if everybody's just bidding half of their valuation, the maximum value a valuation can take is 1, then the maximum bid that anyone can place is going to be 1/2. So if you're bidding more than 1/2, you win for sure, you get VI, but you pay an amount that's BI, which is your own bid, because this is a first price auction. On the other hand, if you're bidding an amount that's between 0 and 1/2, then there's a chance that you might not get the product. The only way you're going to get the product, also, should mention that there are 2 players here. Sorry about that. This game is easily modified when there are n players. When there are n players, it just becomes 1 by n VI, and it's the same logic exactly. We can do that later if you're interested, but for now, let's look at this. So it's a 2-player game, and the only way that player 1 wins, if player 1 is bidding between 0 and 1/2, is if the other player has bid an amount that's less than BI, which is equal to the probability that the other player has a valuation that's between 0 and 2 BI. Right? So let's say I've bid an amount 0.3. Right? The only way that I win the good is if the other player had a valuation that was strictly between 0 and 0.6. Right? Because I need the other player to bid an amount that's less than me. And the probability of the other player having a valuation between 0 and 0.6 is going to be 60%. And so that's what this 2BI represents. It represents the likelihood that the other player will bid an amount that's less than BI. This VI minus BI is what I get if I win. If I lose, I get nothing, I lose nothing, and so that's a 0. Okay. So this is my expected payoff function. On a graph, it looks like this, right? It changes value at the curve changes shape at b equal to 1/2. At b equal to exactly 1/2, these two values give you the same amount. That's this point. Now, the other thing that I'm going to argue is that this curve takes its highest point before that shape changes. Unless v is exactly equal to 1, in which case, unless my valuation is exactly equal to 1, which happens with the probability 0, because it's a uniform distribution. But supposing that happens, then the highest point of this curve will be at exactly 1/2. That said, what we do is we consider this part of the curve. The first order condition to find the maximal point of this part of the curve will be this. That's the first order condition, and that gives you bi equals vi divided by 2. And since vi is going to be some number generated from a uniform distribution between 0 and 1, vi by 2 is going to be less than 1/2, 100% of the time. There's a 0% chance that the valuation is exactly equal to 1. So almost surely vi divided by 2 will be to the left of 1/2. And to the right of vi by 2, this curve starts diminishing. Therefore, the maximal point of this curve will almost surely be bi equals vi divided by 2. And so, if all other players are bidding exactly half of their valuation, then the best response for player I is to bid exactly half of his valuation. And so, this is a Nash equilibrium. Because based off of this, if n-1 players are bidding exactly half of their valuation, the nth player will also bid half of its valuation, and so every player is best responding to other players at that point, and so that's the notion of Nash equilibrium. So there you have it. See you in the next lecture.